So we are live, guys. Yep. Good evening, everyone. This is Ashang David. Welcome back to our DSA live session 13. Today's live session is going to be our 13th live session, and in the last live session we have just finished with a singly linked list and we started with doing our doubly linked list. So now in the doubly linked list concept, we have just done till insert at head, and I have explained you how does a doubly linked list would look like, right? In the previous examples I have explained you also how does a linked list works, correct? How does it looks like, what is it's all about, everything is very much clear in our DSA live session. Anything that you have any doubts, you please let me know in the comment section below, and I'll try to clear your doubts as much as possible. Before I start with this live stream, I would like to just tell you about this, that please try to share this live stream as much as possible. So for those people who are trying to learn DSA for free, I am providing this course, and here we are discussing about each and everything absolutely in depth. So if you have anyone who is learning DSA, please forward this live stream to them, and so that they can also help us grow, as well as they will also grow from learning these concepts. This is Ashang David, and I will be starting off with today's session. So please do like, share and subscribe. If you have missed any other session, you have our same playlist going on. So if you have our same playlist going on, so if you are interested in learning about more DSA concepts, please do let me know. You have to go to our previous live sessions, and you can go ahead and watch our live sessions. From there is a whole playlist. So without any further ado, let's get right into the topic. So let us start. Okay, so in this case here, what we are doing is, we are doing object oriented programming, and in terms of object oriented programming, we are going to not object oriented programming. I just finished with object oriented programming, and then I started saying that we are doing object oriented programming. Well, let us start with our DSA concept, and what we have done is, in the previous one, let us see that also, and we'll continue from there. Okay, give me a minute, guys. Right. Okay. If we go back to our DSA Live 12, that is our 12th session, that was yesterday's session, I had explained you about this. See, the concept of doubly linked list right here. How this is going to get deleted, what exactly is our doubly linked list, how does it looks like, everything I have explained. And yesterday we have just did our insert at head. Okay, done our insert at head. Today we will do all the other functions, and we will finish off the linked list concept. So from Monday onwards, we are trying to do a new concept in DSA. Okay, let me just copy this concept right over to our today's class. Just a minute, guys, not this one but this one. 1 minute, guys. Yep, okay, we are back. Camera went off. I hope so that I am audible and my video feed is coming. If you have any problems related to any sound or video, please do let me know. Okay, right, I hope so that I am audible right now. Okay, but yeah, we are gonna paste this right here. So this is what we have done yesterday. We have just finished up our insert at tail, insert at head, and now we are going to do with insert at tail. Okay. So let us start with our insert at tail. So guys, let us start with our insert at tail. So insert at head, you have already seen that this was the insert at head that we have done in the yesterday's class, as you can see here. Okay, and in here I have clearly explained how this works. Let's do insert at tail. So now I am saying that I need to insert the element right here at the tail, and to do this, what I need to do is I'll have to create a node. Okay, the node has, let's say, 5 as the data, and the node has this 2177 as the address. Take an example, for example, like this. And right now the end part is null and the prev part is also null. Okay, there is no connection there in between. This is the end, of course, and here also this is the end. Right now this is the previous pointer, this is the next pointer, and the previous pointer is saying that I am not connected to anything, and the next pointer is also saying that I am not connected to anything. Now I have created this and I have kept it here. Okay, I have created this new node and I have kept it over there. Okay, but I have not inserted it right now. So what I will do is, how I will insert? If you ask how will I insert, I will say, as usual, I will create what? I will create a temporary pointer, because I want to do insert at tail, no? So I will create a temporary pointer and I will say start from the head, move to the next position, and keep on doing the same stuff, until you reach to the last node. Last node is gonna be this, correct? When the last node has been reached, now temp of next has become null, and when the temp next has become null, our node is already created, so I can just say temp of next, is equals to n, and n of prev is equals to temp. Very simple it is. So in this case what happens is that this connection is now successfully made. So this holds 2177 and this holds 2918, which means this is connected like this now. Okay guys, this is how it will be done. Okay, so that is how your insert at tail will happen. Let us write the code for it and understand it directly, and we will finish it off quickly. Okay, I will go to the code, and in the yesterday's class, as you can see, this is the part which we have already written, and I have told that this is the node class, this is the constructor of that node class, and this is the class doubly linked list, and we have created the head and we have set the head to null pointer, and then we have set that insert at head, and we have done the insert at head function, and then I have said insert at tail. And insert at head function I have already explained this, but now I will be explaining you about and writing the code for insert at tail today. We will do insert at position, delete at head, deletion, and then we will finish this off and we will move on to the next coding, next DSA problem, next DSA thing. Today let us do insert at tail, and let's understand how it works. So, starting from insert at tail, of course you need to create a new node first. To create a new node, what I will write, node star n equals to new node, right. Node star n is equals to new node, and here I will pass the value, correct. And when I pass the value, this happens to be like this, okay. In here I will put up this, and then what I will do, I will have to check if the head is equals to null. Of course, if the head is equals to null, in that case, if the head is equals to null, in that case what we will do? We will call the insert at tail, insert at head, right. Either we can call the inserted head, or I can just like singly linked list, I can say head is equals to n, and then I will just come returning out from that place. Understood this part? I hope so that this part is very much clear to all of you. Next part is, we will start by creating the temp, right. So, I will say node star temp is equals to, start the temp from the head, of course, and while the temp of next does not becomes, temp of next is not equals to null, keep on doing temp is equals to temp of next. You might have understood this. I have made you clear, I have made this clear in the previous class how this thing works. Then later on I said temp is equals to temp of, when it reaches to the last node, what happens is temp of next will point toward n, and n of prev will point towards temp. You got my point? What I have done? We have said temp of next is equals to n. When I said temp of next is equals to n, in that case what happens is that I am saying that this temp of next null doesn't become null, till then keep on doing, and when it becomes null, you said temp of next is equals to n, and n of next is n of prev is equals to temp. So, this way what happens is that this connection is made, and hence this establishment is created. You got my point? I hope so that this is very much clear to all of you, and this is how you do insert at tail. The code is over. Let us run the code and see if it works or not. So, I am gonna just run the code, and you see that let us do some position check. Let me run this code again. Insert at head was this, then insert at tail, of course after 10, of course 30, 80, 90, 100, you can see this. See, first insert at head we did, and we did 10, 20, 30, 40, 50, 60. We did like this 10, 20, 30, 40, 50, 60, and then at the insert at tail check, I have said 10, this was the old one from the head, and this is the tail one from the rest of the part. Understood? I hope so that this is very much clear. So, this is also working fine. So, our insert at tail is also over. I hope so that you have understood this. If you have any doubts, please do let me know. It is very simple to and very similar to singly linked list that we have done, correct. So, this is what it is all about. Understood? Now, next we are going to do insert at position. Now, I want you guys to quickly do the insert at position, because here the very first thing that we need to do is first we will get the size, we will create the size, we will get the size, and I have explained you why we will get the size, because the user which enters the position, that position can be an invalid position, which can be even greater than the length of the linked list. So, in that case you say that, the linked list, in the linked list you cannot do this because the position is invalid. And how do we get to know about that the position is invalid? We will check the size of the linked list from the get size function. And how this get size function works? Very simple. I will just create a while loop. I have created the size variable and I have returned that size variable. Right now it did not do anything, but now it will do it. I am going to say here while loop, but before I create the while loop, I need to create the temp variable which does start from the head. and then I said that while temp is not equals to null, so that is your null. So keep on doing temp is equals to temp of next, and then at the same time you have to do size plus and then return the size, and when you do this enough times, what happens is that the size is returned and this is taken into consideration, and this is going to get the size of the linked list, as you have understood this and we have done this before as well. Okay. So now using that size, I am gonna do the insert at position. So if you talk about the logic of insert at position here, if you talk about the logic for it, then what's happening is that, let us say here you have your, again now we don't require that temp, so I am going to keep that temp away for now and rub this temp off. I am going to create again the temp from the beginning. So here we go, we have created the temp again starting from this. Okay, I have created the temp again starting from that position. And how do we do it? I will say minus position, temp is equals to temp of next again. So in this case what happens is that I can directly say here that temp can move to that particular position. Say for example this is 0, this is 1, this is 2, this is 3. I want to do the insertion at somewhere right here maybe. In that case I can say that the n value is, or the position value is, in this case we will take it as position. So I will say position value is taken as equals to 2. So I will reduce it, so minus position, while incrementing the temp plus. So this is the simple logic that we can do here, and later on once the temp reaches to that particular position, say for example let us say that the temp reaches to this particular location, say for example the temp, we will take the temp from here and we will take it to the particular position, let us say here. Okay, now my temp reaches here and I want to do insertion here. What I will do? I will have to create a new node right there, right? I will have to create the new node right there. I have created the node. Let us say some data is there. So let us say 7 is the data, and here in this case some random 3127 is the address here, and right now this is null and this is also null, which is the prev and the next pointer in this case. Okay. So if I want to do this, then what will I do is I have created the node already right here and my temp is right here. What I will say is I will say n of next is equals to temp of next, right? Temp of next is pointing towards this node, temp of next this is pointing towards this node, which means this node is connected with this node and I want to fill this node. So if I want to fill this up, what I am going to do is I am going to say here n of temp is equals to n of next, that means this part n of next is equals to temp of next, correct? So I can say that right here. So what happens is that this connection is made first, okay, and then I will say that I need to get the value for the prev also. So I will say I will do n of prev, which is this, to the temp back here, right, like this, okay, but I need to do the other way connections also. So for that what I can do is I can say temp of next of prev should point towards n of next, or n basically in this case, correct, because we need to do two conditions, right? And then I can say here that n of prev will point to, or temp of next will point towards n in this case. So like this the connection will be made. You will understand it much better when I will write the code for it. So let us code for it. Okay. So I will start the code here, and we already have got the position. So let us quickly check for the edge cases and finish this off. I will start by creating the size variable, and I am going to call this get size function right there, and I am going to pass the head, or we don't have to pass the head because there is no there. Okay. So what I'm going to do is I'm going to create a newly created node is equals to new node, and here I am going to pass the val. Okay. And then I'm going to check if the position is lesser than 0 or position is greater than the size. In that scenario, I'll say cout. Okay, I will say cout. Wait a second, there is some issue. New node star star node star. There is some issue here. Node star n is equals to new. Value of type node star star cannot be used to initialize the entity of node star. Oh, sorry, here. Okay, now the error will be gone. Okay, see how? Then I'll say here invalid entry, invalid position or invalid entry, whatever you would like to say, you can do it. Okay, we can do it like that. Okay, and else if the position is equals to 0, in that scenario you will do insert at head, correct? So simply taking value and the head, correct? Value only, value only. Okay, because there is no head getting passed anywhere in this case. Alright, so insert at head we are calling, and we are doing it like this. I hope so that this is very much clear of what I am trying to say in this case. And at later on in the else part, I am gonna say, in the else part I am gonna write the actual code, and the actual code will be looking like this. I'll say node star temp is equals to head, and then while minus position, I'll say temp is equals to temp of next, which means the temp reaches to that particular point right there, and then I'll say n of next is equals to temp of next. N of next is equals to temp of next, and n of pref is equals to temp, and then temp of next of pref is equals to n, and temp of next is equals to n. For all the cross connections here, first we have taken the n of next, that means the newly created node will take up the value from its previous temp of next, which means it gets connected to the upcoming node first. Then upcoming nodes, then the ends, the newly created node's previous node will be connected to the temporary variable which is connected. So this way one direction is connected. Another direction is temp of next of pref is equals to n, means the temp of next of pref should be connected to this. So basically the next upcoming node should be connected backwards to the node, the newly created node, and then the temp of next, which is the temp right now, should also get connected to the n right there. These 4 lines are very important in this case, and this is the reason, this is the place where a lot of students get confused, guys. So please do not get confused into this, it's very easy. If you jot it down into a notebook and try to understand how this works, it is going to be very easy. Understood this? Right. Let us continue. Later on, I have to do the delete at head and deletion function. Let's quickly finish this, guys. I hope so that there is no issue in writing understanding the delete function, delete at head function specifically, because here what I'll do is I'll just try to check the head first. If the head is equals to null, if the head is only null, then there is nothing to delete in this case. So what I'll do is I'll say cout, and I'll say the list is empty, I'll just say can't delete, invalid. Okay, I'll just print invalid in this case. Okay, as simple as that, and I'll just say return. Okay, return like that. Okay, and then what I'll do is I'll say node star temp equals to head. This is that to delete which we have created in the single linked list, guys. Okay, if you remember. Understood? Right. Clear? Then here in this case I have taken it out, and then what I will do is head you will point towards next. That means head is equals to head of next. Head is equals to head of next. Now head will move forward, and when the head will move forward, what will happen is if head is not equals to null, head is not equals to null, the head is not equals to null, then the head of prev should also be equals to null, right? Head of prev should be equals to null in this case. This is a very important case, because let us say if you because you see in this case what happens is that, check for yourself. Let us say you are deleting this, so you stored it, then you moved the head here, but what if the head of prev is head of next is there? In that case this value what we are seeing here has to be deleted. Understand the point? And for that reason only we are saying this line of code, if the head is not equals to null, means if this node is being present there, in that case what you do is you say head of prev is equals to null. This way you are not connected to any node also. Jack, hello Jack. We have got a comment. Hello Jack. I hope so that this is very much clear. So now after moving this we need to also delete. So I'll say here delete the temp, and there you go guys, we have deleted the temp. So this is your delete at head. If you have any doubts, so please let me know. This is your delete at head. Is this clear to everyone guys? Very clear? Right. The last function of today's class, that is going to be the deletion function. Now here in the last concept of single linked list, we have done deletion according to the value, right? According to the value we have done. And when we are talking about deletion with the help of a value, in that case we can just take up a value. So we need our temp variable to point towards a particular value. That means in this case we will use the same condition like the one which we have done it in the singly linked list, that is temp of next of data is not equals to value, somewhat like that, right? Here we can say temp of data is not equals to value. Okay, let us see the code right. We will start by what happened? We will start by creating the node star temp, which will start from the head. Okay, and I'll run this temp until the temp of data is not equals to null. Sorry, not null but val. Are you getting my point? I said I am not talking about that I am going one behind the value node. I am saying that I am on to that node, because this is doubly linked list, I can easily travel in both the directions. So I can do that. So in this case I said temp, you start from the head first, temp, you start from the head first, and then you travel until your data becomes there. For example, you are looking for this 7 and your temp started here, now temp reached here. So now temp reached, correct, right here. So now this is your temp, for example. Now when we reached here, what we are going to do is, so I need to first do temp is equals to temp of next, right? Temp of next, correct? Temp is equals to temp of next, correct? Now I will check if the temp is equals to null. In that case we have reached the end and nothing was found, that means this value was not even present. You getting my point what I am trying to say? If we reach null, that means the value was not even present. Understood? So, for that reason I will say that value is not present to be deleted. To be deleted. Okay. I hope so that this is very much clear to what I have said. Correct, right here. Okay. And in that case what you will do, you will just say return. Okay. So, here the value is not present, that has to be returned. And then later on let us say if temp of prev is not equals to null. Temp of prev is not equals to null, that means its behind it is there. You see, if temp of prev is not equals to null, that means it is connected to here. In that case I need to reconnect the wire. So, I will have to say that temp of prev is equals to temp of prev of next. Temp of prev, this temp of prev should be equals to temp of prev next. Understood our point? So, in that case what I will have to say is, in the code I will have to say here that if the temp of prev is not equals to null, then temp of prev of next, temp of prev of next is equals to temp of next. Understood? Similarly, the other way round also we will do. If the temp of next is not equals to null, that means the next node, in that case temp of prev, this will happen the opposite of what we did. Temp of next of prev is equals to temp of prev. You got it? And then at last, to top it off, if the temp has reached the head, that means if it is the first node itself, if the temp is equals to the head, in that case head is equals to head of next. Understood? Then I have said delete the temp in this case. This way what happens is that we have done deletion of the linked list node by value. Sir, should I have to learn C before C++? Yes, because you see why? Because C++ is an extension of C only. So, if you have not learnt C, then you have to, then there is a big struggle in learning C++. So, please do learn C and then you start learning C++, because in C++ we have object oriented, but in C programming you do not have object oriented. C programming is a totally procedural programming language. So, you need to take care of that. So, first you need to learn C programming and then only you will be able to learn C++. I hope so you are getting my point what I am trying to say here, correct? Alright. So, yeah, this is about it. And if we check the code, if we run the code and check, let us see if it works or not. Yes. So, see, insert at head works absolutely fine. Then I said insert at tail works absolutely fine. Insert at position it works. You see 500 is getting inserted in the position. Insert at delete at head, see 60 is deleted. Delete check, I wanted to delete that 500, so that 500 is also checked. This is going to be your end of your doubly linked list concept. This is the whole code for the doubly linked list that we have written, and I have done everything from that doubly linked list concept using the concepts from singly linked list. We have done insertion, all the types of insertion. We have done insertion at tail, position, head, everything. Then we have done deletion, we have done traversal, we have checked everything. Now this part is over now, guys, and in the next class will be on Monday, and the timings are going to get changed a little bit, guys. That on Monday the timings will be on at 7 o'clock in the evening, rather than coming at 6 o'clock in the evening. The timings will be shifted to 7 o'clock in the evening. I hope so that it is going to be clear, guys, because the next class I will be starting with a new data structure. Before that, I am planning that I will be doing one problem. Let us do one problem on linked list so that you have an idea of what kind of problems are asked generally in terms of linked list. Okay. So I hope so that this is very much clear. Today I have finished with the doubly linked list part. So if you have any doubts, please tell me in the comment section. I will try to clear it out as much as possible. And that's it, guys, for today's live stream. If you have liked today's live stream and if you have understood, please do like our live stream and try to share this as much as possible so that this live stream can move on and we can grow together while you are learning and we are growing in the YouTube. Thank you so much for watching our live stream. If you have any doubts into this, we have finished this up as the both singly and doubly linked list. So our concept of linked list is over. In the next class, probably I will start with the concept of this. We will see. According to that, we have to start with the queues, priority queues actually, priority queues, and then we will start with trees. We will do hash maps and all of that we will do. But for this class, this much is enough. I hope so that you have understood this really well. We have finished up the whole linked list concept. We have finished up the stacks and queues also. So 3 data structures are already over. The next time in the next class, I will start with some other data structure or maybe some problem related stuff. So stay tuned for that, guys. And recently I have finished over the C++ object oriented. I know Python. So should I start DSA on? Should I start learning C? If you know Python, you should take some decision what you want to become. You want to go into AI ML field, then Python is good enough for you. If you want to go for development or testing field, then you have to do data structures, of course DSA. So it's up to you of where you want to go. And if you are doing Python, if you already know Python, and if you are into AI ML stuff, then what you can do is you can go ahead and learn more libraries in Python and start with machine learning and artificial intelligence. So that will help you a lot in going into further into AI field and ML field. If you are looking for development job, then for development, of course C++, object oriented programming, C programming, DSA, you can start after that. Jack, got it? Apart from this, also we are trying to provide placements also. So multiple companies are getting into touch with us, and we will try to get into touch with those companies, and we will start providing placements also. So if you think that you can crack an interview and you are eligible for it, please contact us and we will try to help you about the placements part. Well, this is Ashank David signing off. We have also created C++ object oriented playlist. So recently, today only I finished it off. And if you haven't watched that, please go ahead and watch that also. I will put the link of that in the description also. And that's it for this class today, guys. I hope so that this is very much clear to all of you. From my side, this is for this weekend. For this week, it is over. We have finished up C stacks. We have finished up queues. We have finished up linked list concept together. In the next week, we'll start with some other data structure, maybe with trees concept, or maybe heap, or maybe priority queues. It depends upon what we start, depends what we are going to do. We are solve one problem also. So stay tuned for more, guys. And that's all from today's class. This is Ashank David. I'll be signing off. If you have any doubts, please do let me know in the comment section, and I'll try to clear your doubts as well. Okay. I don't see any doubts coming up here, but Apart from any other thing you want to ask me, anything, please ask me. I'll be there for 1 minute and I'll quit the live stream. Live stream went really well, but less students are coming to watch our live stream. I want more students to come, so please do share our live stream also to many people also. I have Mac Air M1, so there is no dedicated GPU. Can I learn TensorFlow? See, of course you can harness the power of cloud computing. You can use Google Colab. Of course, in Google Colab you will be able to things will be able to handle it easily. So don't worry about it. Yes, you can also learn about it. Don't think about too much. TensorFlow, it will come very long, far away. So it will take a lot of time to learn TensorFlow. But till then, at least you should learn about all those things. So keep on learning. Don't think about all these things. Nothing can stop you from learning anything. So it doesn't matter. You can use Google Colab though, and Google Colab will allow you to learn TensorFlow even much better. Alright. So, and if you have a Mac, yes, you can easily do Mac Air M1. It's awesome for doing that. No problem in doing anything related to it. Okay. Well, that's it. Any other doubt, Jack? Please let me know. I'll try to clear that off as well, and we'll now finish this live stream. All right. I don't see any comment now, so I will be closing this live stream, guys. Thank you so much for watching. Happy weekend, guys, and if you have any problems, please do let me know in the comment section. That's all for today's class. I'll be ending the live stream now, and yep. Alright, guys, thank you. I'll be going offline. This is Ashank David signing off. No more comments. Let's go. Happy weekend, guys. Bye bye. This is Ashank.